Hey YouTube, it's JP Dillon. Today we're looking at a Luxman K-112 3-head cassette deck. This was brought in by a viewer of the channel, and it's been sitting in a box for a while, and it's in very nice cosmetic condition, but there is a point of concern that's going to require the replacement of the motor, and I'll show you that in just a moment. This is a very nicely built deck. It has a very simple but decent transport. It's got a remote control, although I don't know if he has that or not. And I did a brief examination when it came in, and I'll show you what's going on with it that prompts the motor replacement. As you can see, if we just kind of zoom in here a little bit, that's your tape transport. And we turn around here, shed some more light on this. Now, for a 35-year-old cassette deck, one thing I notice is that really nice looking fresh belt there. Well, therein lies the problem. And the problem is somebody replaced this belt and they used something that was too tight. And as a result, there's motor runout side to side. Front to back is okay. Side to side, not. It goes clicky clicky. So this motor's trash. And although it does run, the speed is kind of funky, and it definitely needs the correct belt and the correct motor replacement. Now, thankfully, this is a Mabuchi motor. It's the EG530, or this one's the 500, which is still readily available, so that's really not a big deal. I believe I have a 530, which should be the same thing, but the difficulty is replacing the pulley. The pulley on here is usually a press fit, like this one is, and it's a little bit tricky to get that off there without bending or damaging the pulley. And then, of course, there's actually removing the transport as a whole, but that's not too tricky either. So what we want to do is get this thing apart to the point where we can remove the transport and get it out of here. And the first thing that we're going to do is we're going to cut all the zip ties that hold the wiring harnesses together. The reason why you do that is for ease of disassembling, because some go to the front panel, some go to the board, and you will have to separate them in order to get the backing plate off for the motor replacement. So the majority of those cables just unplug like this here. This is your signal cable. There's also another one over here which you can cut this tie on. I believe this one is specifically for the record head and the bias. And then you've got another one up front, which, as I recall, is your tape motion stop detector. You'll also need to take the door off. Just grab it, and there's two little clips. This is always the fun part. You want to take it off without breaking it. Clips on the side usually just release, but these ones are a little bit old and brittle, so I'm going to very carefully pry, very carefully, and see if I can't get them loose. And of course, this is the one that's going to be stubborn. Let's try a wider blade so I can get in here a little bit better. They're on the top sides here. Man, I've never had one give me this much trouble. There we go. That part's come off. Got the bottom part there. There we go. Ha! What a pain. Never had that much difficulty with one of those. Okay, let's take a look inside here. Good looking pinch roller. You see there that we have a nice looking head. If it'll focus for me. Minimal wear. Definitely needs some cleaning, but not bad at all. One thing you got to watch out for, and you can do the fingernail test, is press down on the pinch roller and make sure it's soft and it doesn't leave a divot when you push on it. So that pinch roller is in okay shape. That'll clean up nicely. Okay, so let me put this back in the holder, and then we can start taking the transport out. Now that we got the door off. If you don't take the door off, you'll never clear the well for the transport. Okay, holder's being finicky today. So, I'm going to start with screws up here. And there's two more at the bottom. So we have to switch to the shorter one. One more to go after this one. You can already start to see it coming loose. And just the one down here. Assuming there's no other impediments, it should just come out like that. This one's not attached to the door. Usually this transport is. Anyways, let's get this out of the way. There's our cute little transport. Let's set this aside. We can listen to the people next door argue about who's going to exit the driveway first. And let's get up on this thing a little bit so we can see what we're doing. So this is the transport. Very well designed. As you can see, there's no silly idlers to go bad. It's all direct driven. No clutch either. This is entirely direct drive, and the torque is determined by the microprocessor. And I believe it's supposed to be around 15 to 20 grams centimeters. So we'll double check that when we put that together to make sure it's not too high or too low. Too high and you'll pull it past the pinch roller and cause wound flooded problems. Too low and it won't grip. So that's something to pay attention to. One thing I notice, let's see if we can zoom in on it here. A point of concern is that little split in the plastic there. I don't know if you can see that. If it'll focus, there we go. The split in that plastic for the retainer. And this is a back tension while it's in play. And what I will do, if it's not busted already, is I'll take a soldering iron and I will fuse that crack together very carefully so it doesn't split and get worse. Because if it does, and this comes off, then you've got no back tension and you've got more problems. So anyway, that's been taken care of. And there's this little spring here, which I never understood why they used a spring. If it's a grounding apparatus, they could have just used a hard wire, but make sure, obviously, you detach this spring and retain it, because you'll need to put it back. Even if it is attached at the back side. I never leave them attached because, knowing my luck, it will come detached while I am servicing it. The little spring will get lost and I'll never ever see it again. I'm just going to put it in my little tray of things up here. Okay, so the next thing we're going to do is take the back plate off, and I want to take stress off of this. That's the little solenoid that fires the play system. Don't need those wires getting yanked out. That would be a bad thing. So we're going to take this loose a little bit. I like how they have them wrapped up in there, so as soon as you try to move this clamp, it tries to destroy the solenoid. That's nice. And we're going to separate the solenoid cable with the signal cable there. And we're going to take the clamp loose and the terminal strip, and that will just kind of hang out at the bottom. And then we'll get an appropriate screwdriver. Take this loose too. And then we'll take the back plate off. Come on, you get out of there. And then the final one is up top. Now, before you let this go, take a good look around the perimeter and make sure there's no springs or anything funny holding it together. There's a lot of tension on that belt. Just wanted to pull right down. And you can see, for the time that it's been inactive, that belt had a really nice crease in it from pulling on that motor pulley. There's no elasticity to that either, so it's just gonna die. And it's gonna kill the poor little motor. And while we're at it, we're gonna carefully remove this. And we're going to put a little dab of turbine oil on the capstan bearing. Stick it back in there. Actually, before we do that, make sure this cam is free moving. This one is. The grease gets sticky here, and you'll get problems with it coming up and cycling and stuff. So make sure that that's free moving. This pivot point here and this pivot point here. Most of these don't use grease. There's older iterations that do. These ones usually do not. So we'll put that there, give it a nice little spin down test. That's a good bearing. And then what we'll do is grab our motor plate, assuming that I can detangle it from the plethora of wires here. And I'm going to mark, well, actually, it's not really needed because the pink is positive and the black is negative. That's pretty straightforward. So let me desolder this. We'll just give it a little tug as we desolder. Comes right out. And you see this silly little wire here that grounds the motor case to the chassis. You have to retain that, otherwise you'll get a buzz in the sound. It comes off fairly easy. And then we'll dismount the motor. The grommets will usually hold the screws in place, so I'm not too worried about that. So this is your motor with the clickety clackety clack. These are usually glued in here. Now, one thing you want to do before anything else, assuming your cohort hasn't run off with your machinist's rule, which apparently he has. Lovely. Well, anyways, I can usually eyeball this stuff. That looks like about about 3 millimeters between the deck of the motor as it sticks up and the bottom of the pulley. Now, what you can try to do first is gently pry with a very slender pair of needle nose, so you can use the largest amount of surface area possible to distribute the force, so you don't bend the pulley, and just slide it in there and push and push and push and push. And what you're doing is you're slowly pressing this off, and you're not prying, because if you pry, you will destroy the pulley by bending it. See how that comes off? It's just pressed on there. So this is the old motor that goes away. So let me grab the new motor, and we'll start the installation process. Okay, so the new motor that's going to be used in place of the old one is the EG530 AD, which is also a single-speed counterclockwise motor. And as you can see, the size is a little bit smaller on the new motor, but I believe the mounting centers are the same. If not, we're going to have to get creative, or I have another version of this that has the bigger body. But otherwise, it should be the same. Let's do a quick test mount before we go nuts about mounting the motor on here. And I'm probably going to have to get the one with the bigger body, but we'll see. So we got one screw here, got one screw there, and we got one screw there, and it mounts just fine, just like the old one, so I don't have to do any mods or find the other motor. So same deck height. So let's get our pulley on here, and we'll mount the motor up. And of course, make sure it's counterclockwise like the old motor. So let's see here. This is going to be the bottom side because it's got the pry mark. Now, as you can see, this is kind of loose and sloppy. So what you want to do, don't use super glue. I know that the temptation is there, but don't use super glue. What you want to use is a nice strong Loctite, because if you use super glue, the risk of it trickling down into the motor bearing is real. It does happen. I've had it happen. Not good. And then you've just wasted the time installing the motor. So let's get the Loctite, and then let's apply it to the shaft there. Alright. So a little bit of the 3-bond, which is more or less Loctite. You thought I was going to put it on the shaft, didn't you? Nope. Push it inside the pulley there. Because if you put it on the shaft, it'll get pushed down into the bearing. If you put it inside of the pulley, it'll get pushed into the pulley. Also make sure to clear away any excess. Let me grab a Q-tip here real quick, because I want to make sure that there's no probability of that getting down into the motor bearing. And we'll just push this on here, get it firm against the motor pulley. And if you get an air pocket like I'm getting right here, get a little pick and stab it. And that's got to cure before you can spin it up, because obviously the glue is going to be the majority thing holding it on there. So make sure that you've got it, let it cure for a while, and we'll come back to this. So that way you don't have to worry about the pulley slipping and sliding when you go to do your tests and stuff. Alright, so we'll come back to this. Okay, so while we're waiting for the motor to dry, we're going to do some basic maintenance on this transport. And that really just consists of cleaning the heads, the roller, the tape path, and that's pretty straightforward. Get this up in a position. You can kind of see what's going on here. Use the old motor to prop it up. It's got to be useful for something now. So Q-tip and some 99% isopropanol or denatured alcohol, acetone. Yeah, acetone's a little volatile and probably more harmful for you. So we're just going to clean the heads and the capstan, anywhere that the tape goes over, really. And the camera's going to shake there because I've found the parasitic oscillation. Clean the pinch roller. Since the rubber's in really good shape, don't really need to do a whole lot else. The tricky part's going to be finding a belt that works, because obviously the reason why the old motor died was because somebody used a belt that was too tight, which is a very common thing I see in this field. Actually, you'll see these people that'll buy these belt kits on Amazon and the like, and it's like, hey, it fits this model, but it really doesn't. And so when the person goes to try to install the belt, they're like, wow, this is kind of snug. And, you know, then they find that the speed's way off, and they got to reset the speed. And it shouldn't be that far off if the new belt is similar to the old one. Let's clean this too. Make sure that's nice and happy. I already cleaned the motor pulley, so wherever the belt's going to go, that should be nice and clean too. Make sure that that is happy there. I'm just making sure that the machine cycles. It does. Alright. But yeah, gotta watch out where you buy belts these days. And it's getting harder and harder to find cassette belts, especially for Nakamichis. And I thought that perhaps using the Russell Industries belts for the Nakamichis work, but what they advertise is the I think it's the FRW 6.5. Doesn't work with a crap. It's molded bad and has terrible wow and flutter, so I don't use that. And I don't know where this old belt came from, but it's hella tight. It has no stretch, and it's got that nice divot in it from resting on the motor pulley for however long it was stored away like that. It's sad that it killed a perfectly good motor, but that happens if you don't use the right belts. And sometimes you have to open your wallet a little bit, Shango says, and you have to buy different belts. You have to buy a whole bunch of them that are close to the right size and see which one works the best. And in my case, I always stick it on the wow and flutter meter and see what works best. And whatever doesn't work best just gets stored away somewhere else for another project to try. And it means that the average cost to service it is more money than it would be if you just had a functioning belt that you knew worked. But we don't have that luxury anymore. Mars Communications made a great product, but they never get it to you. And I think they're currently under investigation. But you didn't hear that from me. And it's Studio Sound Electronics in Hollywood I used to use for belts, because they had these awesome belts. But they no longer have belts. I guess their supplier is not making them anymore, or they lost the contract, or whatever's going on. Doesn't matter, they don't have it. And they referred me to turntableneedles.com, which sells belts, and I bought some belts from them that didn't turn out, but they're trying to work with me on that and get me some better replacements from their different suppliers, so we'll see how that goes. So I'm going to have to use what I have in my inventory to see if I can make this one work. But anyway, I'm rambling on again, so we're going to set this aside, and next time when I come back to the motor and the motor's happy and dry, we'll reinstall it and see where we go from there. Okay, so we've waited a fair amount of time overnight, and we're going to try to stick this motor back in here now. Now that the glue's set on there, the pulley's not coming off. So let's go ahead and put it back in. The orientation was such that the terminals were about at this point, and I think we should have no problem in getting that back in there that way. We just need to grab the right tool and find one of the screw holes here at the back. There we go. Start threading it, and then we'll have to reattach that ground wire too that it wants. Thankfully we didn't have to modify anything. Yeah, that height is really crucial, because as you can see, the edge of the pulley just comes above the deck, and the belt's probably going to ride in that groove right there. We'll see how that works. That looks nice. So now where's our little ground wire? There's our little ground wire there. I have to rough this up so that the solder has something to stick to. And I'm actually going to go at the back cover here rather than on the top plate, which is just pressed in, so that if the motor ever has to be taken apart, God forbid, that the wire doesn't have to be unsoldered. So I rough that up, and we'll get our soldering iron. Keep bashing the camera mount. Stop that. Okay, there's our abrasion. We're going to heat that up, heat the work area. Alright. Then we'll solder our little wire to it. Assuming my dexterity is good enough to do that. There we go. Okay. So now we've got a motor on there, and that little ground strap will go back to the point there. Let's find our motor leads, pink and black things. And pink's going to go to positive, and black's going to go to negative. Okie dokie. And then we'll solder these bad boys up. And then we'll have to figure out what belt's going to work. Wait for it to harden, give it a good yank test. Alright. So there is our motor. And we're going to do a quick look at this. And we see that the pulley is in fact in line with the smaller of the two tiers on the capstan. It's kind of what I figured. So that's going to ride there. Okay. Now, the distance between the side of the capstan and the pulley is about 1 inch in space. And the actual flywheel itself is about 3 inches in diameter. So if we do the circumference, that's about 6 inches plus the distance plus the diameter of the motor pulley. plus maybe 5 to 7% stretch. So I'm going to guess about 6.8 inches for a belt. So let me go get some belt sizes and we'll test that theory. Okay, so I'm going to start off with something a little larger, which is an FRW 7.3, which is actually somewhat larger than my projections, but it's better to start larger and go smaller. So here's our FRW 7.3, and according to the specs, it's a precision mold with 0.02 thickness and 0.14 wide. So that's a precision belt. That's pretty thin. Let's see how well this fits. Might be a little loose based on my projections, but we'll find out. Right now it's just struggling to stay on there. Yeah, that's really loose. You can see the belt wiggle and wobble through that window there, which tells me that there's just not enough tension on it. So the 7.3 is out. That's not going to work. So the next one we got is a 7.1, which is a hair thicker. It's at 0.025, which is about as thick as I'd want to get for a belt like this. And it's 0.16 wide. Okay, so let's see if here's the little product placement there. It's the FRW 7.1. Let's see if this one works. This is also a precision molded belt. It's pretty thin. Let's see if the 7.1 works, because I was guesstimating 6.8 and the 7.3 is way too loose. So let's try the 7.1. The 7.1 could actually work. That could actually work. Holding the motor pulley, we get a little bit of flex there, a little tiny bit, a little bit of slippage, but nothing that would be harmful to a motor. So I think I'm going to go with the 7.1. We'll try the 6.86 I have, which is one of the last Studio Sound Electronics belts I have. But I think that might be a little on the snug side. So let's put the 7.1 aside. And I don't have anything other than a generic bag they sent me for this FBS 6.86. But that's also, this is a 0.14 wide and 0.025 wide thickness belt. You can see it's very thin there. Thin is the key. Let's try the 6.86. Assuming I can thread it on the pulley here. Oh, that actually might work better. Let's that actually feels better. Still got a little bit of flex there, but that actually feels better. So I guess my my hypothesis wasn't all that far off. So we'll set the 7.1 aside. We'll try it with the 6.86. It'll be interesting to see what our wow and flutter numbers are at once we get the transport back in. Okay, let me get another tool and we'll start putting the transport back together. I gotta make sure that's all out of the way. Deal with that in a minute. Getting ahead of myself. Now it's nice to have that little window there so you can see what the belt does while it's on the pulley. a little bit of flex when you hold the motor pulley and force the belt to move along with the capstan. That kind of tells you. If you don't see that buckling or anything like that, it's probably too tight. A tiny little bit of movement is good. Too much movement is too loose. Anyway, that's just how I gauge it. Your mileage may vary. We got to make sure the little grounding screw for the motor is here. And I'm sure the motor speed's going to be way off because they just set these at whatever when they leave the factory. Can always tell when the secretary's there. Her shoes give it away. Okay, and let's reattach our solenoid wires here. Trying to get that to thread's going to be the fun part while I'm holding this. There we go. Okay. Let's get this up and out of the way like it used to be. And then we have the motor mess and wires here. Here. Okay. No wandering on that pulley. It's just kind of there. And it is going around the apex of the pulley, the center of it, rather than riding on an edge, which would tell me that there's something wrong with the mount or this is crooked or something like that. Okay, now it goes back in the set. Alright, so let me move this so we have a better view. Assuming it will stay put for me. All right. We'll start with the top two. And switch screwdrivers to the shorter one. Come on now. Don't try to fight it. Remember, it's always easier to take the transport out than it is to put it back in. Okay, and then finally, got to do the one over here. Let's get that threaded. Alright, physically attached. Let's go ahead and hook all the electronics back up. last one. Plugs back in there. Okie dokie. So we replaced the motor, we replaced the belt with something more sensible. Now it's the big moment of truth, and we're going to see if this, first of all, functions. Motor spins all the time. Let's see if it goes into play mode by me messing with the sensor switches. It does. Alright. So now we have to set the speed and check our wow and flutter to see if our motor replacement and the belt do a decent job. So the first thing I'll do is we'll set the wow and flutter meter for speed. Okay, and I'm going to try to pan out here, and you're going to want to watch that guy up there. Let me get a test tape. Hit play, and you can see we're a lot slow. So I'm going to adjust the speed. Alright, and let's look at our wow and flutter. Not bad. So I'm on the 0.1% scale here, and we're reading about 0.045, and that's pretty consistent. So that's a good combo. There we go. So you can see it better here. But there we are. So no bullshit. Weighted wow and flutter 0.1 scale, and it's 0.045. If we just go with the standard wow and flutter, it's about 0.09. So that's very good. Very, very good. That's a happy machine right there. Speed's nice and happy. So that's excellent. Did it on the first try. Okay. So let's clean a couple of these switches and pots with some deoxit, and then do a brief musical fidelity test and see how it sounds. Alright, so I got all the pots and switches cleaned. We're going to check the alignment, and I'm just going to leave a high frequency test tape in there. I'm going to hit play, and we're going to take a look at the phase relationship. And you can tell it's good wow and flutter because you don't see very much there. Now we have a little bit of phase deviation there. If you go like that, you can see that. And so there's head alignment screws underneath here. If it will focus to it. That guy right there. And I'm going to use this because it's a non-magnetic tool. And you don't want to screw with the head alignment with a magnetic tool. You'll magnetize the head. So watch as I turn the head alignment screw. You can see that it's correcting the phase. And that one's picky. There we go. That's pretty close. A little bit of drift. Get it a little bit better. I think I've almost run out of adjustment. Yeah, it's about as good as it gets. It's pretty damn close. I'm kind of out of adjustment there. But that's good. That's very good. I'm happy with that. So we'll take that out. If you don't have an oscilloscope, it's hard to tweak the heads. I wouldn't do it just for high frequency response, because a lot of your sound stage is in stereo phasing separation, and if the phase isn't right, then yeah, you could have high frequency response, but who cares about anything else? Yeah, it sounds good, but if you actually try to go for a stereo experience, it doesn't happen. Alright, so let's get the audio cables here. Now I'm only going to be able to play this for a short time because of copyright reasons. Let's see how this works. Am I between songs? Yeah, I am.
I'll find me a lonely lady.
Plays the chromium oxide tapes pretty good too. Alright, so I'm pretty happy with the fidelity of this thing overall. It's got decent heads on it, nice sound. As I mentioned at the beginning of the video, we need to check and see that the real torque is consistent, since it is governed electronically and there's no clutches. So here we have a little torque meter which we can observe take up torque. And if I hit play here, I've made a mark on there, and we can see that it's pulling about 30 grams centimeters. It's a little on the high side, but it's not terrible. The wow and flutter proves that the system's working correctly. It's got very low wow and flutter. It's pretty awesome. So I'm not worried about that. That's in excellent shape. Alright, so let's button this thing back up. Alrighty, so she's all back together. This one's ready to go home. This is a nice deck. 0.045 measured wow and flutter, weighted in about unweighted about 0.09. That's just excellent. So we were lucky to get the belt right on the first try. The new motor is decent, so this should give many years of service. The heads are in good shape, has nice fidelity. So I hope you all enjoyed watching the video. Hopefully this will help you in servicing one of these if one comes across your doorstep. I think that had I not had the 6.86, the FRW 7.1 would have worked. I did not prove that, and I'm not going to tear it apart to prove that. If I find another one of these things, I'll probably do that just to try it out. But it's close enough that I think it would work. But the FBS 6.86 does work very well. And again, that's my old stock from Studio Sound Electronics, which I don't think carries belts anymore. At least last time I talked to them, they didn't. That's unfortunate. It's another good source that's gone away. So, hope you guys enjoyed the video. Thanks for watching. Click like, subscribe, blah, blah, blah. Make the channel grow. It's up to you, and I am very grateful for my viewers. So thanks again. More stuff to come as I have time.